Okay, so let me give you the kind of the basics here of how this thing works. Let's do the slideshow right here. All right, an RC circuit. I think your quiz might be give me three examples of how an RC circuit works. All right, I want you to write those down. I want to see who's watched this. I'm just going to start and you're going to turn that in. All right. So give me three examples of what we use an RC circuit for. All right. So anyway, here we go. Notice this is an RC circuit. This is a direct current, direct voltage. So it's a direct current. We'll get into alternating current in chapter 20. But anyway, here we go. We've got charging up, so nothing's going on. We throw the switch. Zoom. Current starts right away. All right? Current starts right away. It's at a max. The current is at a maximum here. The current actually goes in the opposite direction of how the charging and the voltage goes. What do I mean by that? The current has a formula that's a little bit different. All right, quite a bit different actually, because it's slowing. The current will slow down as this capacitor builds up, because eventually what happens, you get all of this stuff built up in here, and so that's why we have a different switch over here when that's all built up. And we have a different switch over here that goes clunk, and then these particles go running through that thing over here, whatever we have over here in the case of the defibrillator. Okay, so the same. So then eventually notice what happens. The current almost comes to zero because it can't go any further. It's all filled up. It's all filled up. So the thing is completely charged. And it's a different, oh, here we go. Sorry. And it's a differential equation, so that's why it looks funny. It's basically, this is a growth, this is a growth exponential differential equation that is solved, and this is an extinction differential equation that is solved. All right. And more fun with math. I'm just going to throw out a few little tidbits here. More fun with math. I hate to say it, this isn't fun at all, but the great apes, elephants, tigers, all these large animals that we're trying to protect and everything, they are already on they are already in on this graph. Extinction is inevitable. It's horrible to say, but once something gets here, it's done. Once it's here, it'll eventually taper off, and then it'll start to decline a little bit and then probably grow again. We're trying to get it to grow again. I don't know if it'll happen. All right. Anyway, voltage has a function of time. This is solved from a differential equation. So V equals 1 minus e to the negative t over RC. What is that? All right, let me write that out. So the charging, VC for charging, and this is the current is a function of time. All right, the current going through. So right at the very start, let me write this. Let me show you. I get excited. All right, so here we go. Here we go. Myself here. All right. So this is our September 16 notes. This is I like this stuff because it's real stuff, and most of y'all are pre-med, and we should all know how to use a defibrillator. I'll be honest, I don't. I've never used one. It doesn't look that hard, but you could die if you don't know how to use it, and you could kill somebody when you're trying to save their life if you don't know how to use it. But anyway, so the charging is equal to what that's like. I want to make sure I get it right because I'll get all carried away. Oh, yeah, V naught 1 plus. I knew there was something I was missing there. All right, is equal to the voltage of the battery times 1 plus e to the minus t over RC. And then the current at any time during charging, this is the current during charging, we'll say, is equal to I naught times e to the minus t over RC. Now this is huge. Wait a timeout. That was minus, wasn't it? Yeah, I knew it was. Had to be minus. All right. September 16 notes. Let's start over. I'm not starting this movie over, but September 16 notes. I'm going to write these neater. Now, the problem that I'm having right now is that our copier is down and I can't get quick and dirty PDF files. So I have to send these to you one page at a time. It's really annoying. But anyway, all right, so charging 1 V naught times 1 minus e to the minus t over RC. The current during charging is equal to E naught, or the initial current, times e to the minus t over RC. And we'll talk about what RC is in the circuit. Well, R is the resistance in the circuit, and C is the capacitance. And that's called the time constant. All right. Second quiz, I'm writing down these quiz questions. So the second quiz question is going to be, show why R times C comes out to be seconds. Ha! Knock yourselves out, because it'll be on the next thing. All right. So there's the two equations. Now, what I want you to do is, let's just take a look at this piece right here. This e to the minus t over RC. That can also be written as 1 over e to the t over RC. So when t equals 0, what is anything to the 0 power? It's 1. All right? So when t equals 0, this term is equal to 1. All right? But what about when t goes for a long time, out to infinity? Okay? So remember, e minus t over RC is equal to 1 over e to the t over RC. Okay? So if I've got 1 over some number to infinity, what does that equal? You're right, 0. So that goes to 0. So you can see, as t gets bigger, this term, so let's look at the charging term here, V naught times 1 minus e to the minus t over the time constant RC. You can see, as this guy goes to infinity, that drops, this becomes 0, and then VC will equal V naught. All right? More on the math on the next slide.